Right, so just a quick run through on the material on Surds for Leaving Cert Higher Level Maths. Here are some of the Surd rules or ways you can work with them. Okay, pause and take note if you need to. Some of the things you may be asked to do with Surds, or if you want to work with Surds easily, the first thing is to rationalise the denominator. Now, what does that mean? This means to leave a denominator as a whole number without a square root. Remember, to keep the value of a fraction constant, the same must be done to the top and the bottom of the fraction. And also remember that root x by root x gives x. Okay, so rationalising the denominator in the following. So 6 over root 2. So to rationalise means to not leave a root under the line as a denominator. Okay, so what might we choose to do? So if I go through this bit by bit, I'm choosing to multiply the fraction by root 2 over root 2. Okay, so here, root 2 over root 2 is equal to 1, so you're not changing the value of your fraction at all. You're doing the same to the top and the bottom. So why do we choose to multiply by root 2 over root 2? Well, the reason is because root 2 times root 2 gives 2, a whole number. Okay, so the top line 6 by root 2 gives 6 root 2, and underneath we have 2. When you divide that 2 into the top line, you get 3 root 2, and it is rationalised. So what do you think will multiply this one by? Well, yes, it will be, in this case, we've split up the roots, okay? So you're allowed to do this if you want easier numbers to work with, okay? So we've written root 30 as root 3 times root 10, and root 20 as root 2 times root 10. Now, you don't have to do that. You could just multiply by root 20 above and below. But to work with easier numbers, we can do that. Root 10 over root 10 will divide and give 1. Okay, so that goes. And then to rationalise, just like the previous question above, you multiply by root 2 over root 2. Okay, so root 2 times root 2 gives 2 underneath. And root 3 by root 2 gives root 6 above. Okay, and that would be the final answer. Your calculator automatically rationalizes fractions. Okay, so sometimes the answer you get in your copybook might look a little different. Where are the root signs? And the reason is your calculator has already rationalized your answer. Okay. So rationalize the denominator in the following. Okay, so this one is a bit different. You have 2 terms above and 2 terms underneath, and one, it's like a division. There's no way we can divide there as the 2 terms underneath are separated by a minus. How will we deal with this one? Okay, so I want you to think back to your factorizing at ordinary level and the difference of 2 squares. So, and the factors were the same. The only difference was one had minus and one has plus. And the result was that the middle term disappeared. Now we're using similar thought here. Okay, we're going to multiply by the conjugate of the denominator. Now you meet conjugates also in complex numbers. So conjugates are very similar, just a sign change. This is the denominator with the central sign changed. It works to eliminate middle terms of multiplication. So let's look at that. Okay, so we're multiplying by the conjugate of the denominator. So what's underneath? Okay, that's 5 minus root 3. So we'll take our original fraction and multiply by 5 plus root 3 above and below. Okay, keeping our fraction of the same value. Okay, So it will be a big long multiplication, okay, a 2 by 2 multiply on top and a 2 by 2 multiply on bottom. But the key thing is that underneath you'll have 5 5s or 25. You'll get plus 5 root 3 minus 5 root 3. That's the key thing. You have plus and minus. And so together they will eliminate each other and become 0. So underneath you now have 25 minus 3, which is 22. Gives me a denominator there of 22, a whole number. So we have rationalized. Okay, so I suggest that you start back with the original question, take a piece of paper and work it through yourselves and see do you get the same result. Okay. Now, higher level equations with surds. So how do we deal with these? So I go through just the logical steps that you'll take here first. So it asks you to solve for x in each of the surds equations following. Okay, the method is to square both sides to eliminate square roots. So if you're doing the same thing to the left of the equation as the right of the equation, your equation will stay true. Okay, so the technique is to square both sides. So squaring will get rid of the square root sign. Okay, now to avoid any messy middle terms, so introducing more square root signs, you begin by isolating square roots on one side of the equals if possible. So put it to one side before you square left and right. And you will find questions like these in the Algebra 3 chapter. So here's a simple example. All right, root x plus 5 equals 3. So we have to solve for x. We'll begin by squaring both sides. So squaring a square root just gives you whatever's underneath, x plus 5, and squaring the right-hand side gives you 9. And then you can solve for x, and you get 4. So there we see squaring both sides working. Okay, of course it doesn't stay so simple. Right, let's look at this one. So the square root extends over two terms, 3x minus 2. Then you have plus 4, and on the right you have 5x. So as we suggested before, you first isolate the square root. Okay, so we take 4 from both sides and we have 5x minus 4 on the right. Okay, when you have the square root on its own, now we will square both sides. Okay, so the left hand side just becomes 3x minus 2. The right hand side will give you a quadratic when you multiply that out. Okay, we recognize the quadratic with x squared terms, x and constants. To solve quadratics, we must have them equal to 0. So that's your next job. Put all the terms on one side of the equals and equal to 0 on the other. Okay, now how do you solve a quadratic equation? Well, you have choices. Maybe you can factorize, or if you can't find the factors quickly, you can use your minus b formula. Okay, so next page. So using your equation, a is 25, b is minus 43, don't forget the minus, and c is 18. Okay, now you can use your scientific calculator. We'll do it all at once for you, which is fantastic. Remember, once we use the plus sign and once we use the minus sign, give us two answers. The first answer is 1 and the second answer is 18 over 25. Okay, so what I ask you to do now is to rewind, get the original question, get a new piece of paper and work through from start to finish and see do you get the same answers. Okay, now here we get things that are a little bit more complicated. We have two surds in this equation. So we can't isolate them completely. okay? But what we will do, because otherwise it would be really messy, what we will do is we'll separate them, we'll put 1 on both sides of the equals, like that. So we've moved root x plus 2 to the right, okay? So we do have to square both sides, but you'll see it won't be as straightforward as before. So the left-hand side is straightforward, we get x plus 7. But the right-hand side, when you square it out, you get these messy middle terms here, okay? Minus 5 root x plus 2, okay? And root x plus 2 squared gives us that x plus 2, okay? You can combine the 2 minus 5 roots to give you minus 10 root. Adding your numbers, you have 25 and 2, give me that 27, and I have a plus x there. Okay, so we have square root both sides, but we still have a square root. Okay, so basically we go for round 2, we start again. So first we tidy up the other terms. So you have x on both sides, meaning you can remove x from both sides, that disappears, or if you bring it over you get x minus x, and you have 27 minus 7 gives you 20, okay? So we are in a better position now that we only have one surd in the equation. Pause if you need to here at this stage and review all the workings. Otherwise we'll go to the next page to finish the question. So we go again. So this is what we have now, and we'll work with this. So firstly, we can divide both sides by 10. That will make things look nicer. So you have root x plus 2 equals to 2. And we're going to square both sides. And we get x plus 2 equals 4. And solving for x, we get x is 2. Okay, so bit of a long question paper-wise. Okay. We had to go around the method 2 times because we had 2 square roots in the original question. Again, if you want to rewind, take down the original question and try it for yourself and see how far you get, and you get to the answer. Don't forget to check your answer, of course. Whenever you get an answer, you go back to the original, plug in x equals 2, so sub in 2 instead of it and see does it work in your original equation.